Hi, my name is Jason Leonard. I'm a Design Engineering Manager for Power Products here at Linear Technology. Today, we are introducing the LTC3639, a new 150 volt input, 100 milliamp output synchronous step-down regulator that's easy to use and offers very high efficiency while consuming only 12 microamps of quiescent current. Let's look at the key features. The input voltage range is 4 volts to 150 volts, making this part great for a wide range of applications, such as automotive, industrial, avionics, and communications. The LTC3639 offers high efficiency through its low 12 microamp quiescent current and its integrated low resistance top switch and synchronous bottom switch. The top switch is also capable of 100% duty cycle, providing an LDO-like dropout performance when the input voltage is below the output regulation point. The output voltage can be set from 0.8 volts to as high as the input voltage with an external resistor divider. The LTC3639 also includes 3 pin-selectable fixed output voltage settings of 1.8 volts, 3.3 volts, and 5 volts, minimizing component count and noise for these common applications. The LTC3639 also features a resistor programmable peak current threshold, which can be programmed to limit the peak inductor current from 20 milliamps to 200 milliamps. This enables efficiency and component selection to be optimized for load currents from 10 milliamps to 100 milliamps. The LTC3639 needs only a few external components and requires no compensation. When using a fixed output voltage setting, the LTC3639 only requires 3 external components: an input capacitor, an output capacitor, and an inductor, providing high efficiency with only one more external component than an LDO. The LTC3639 is available in a thermally enhanced 16-pin, high-voltage capable MSOP package with 4 pins removed to increase the spacing between the low-voltage and high-voltage pins. Here is an example of the LTC3639 in an industrial or automotive application. A resistor divider has been added to externally program the output voltage to 12 volts, and the iSet pin is floating, which programs the output current to 100 milliamps. If we wanted to limit the output current to between 10 milliamps and 100 milliamps, a resistor could be placed in the iSet pin to reduce the current. In many applications, low dropout operation is necessary to maintain as high of an output voltage as possible when the input voltage falls below the regulation point. You can see in this figure that the LTC3639 has dropout performance similar to an LDO. Unlike an LDO, the LTC3639 provides high efficiency at high input voltages. This graph compares the efficiency of the LTC3639 to the efficiency of an LDO. Here you can see that while the LDO efficiency drops off dramatically at high input voltage, the LTC3639 efficiency remains above 80% all the way up to 150 volts. If we were to look at the application circuit of a typical LDO, it also requires an input capacitor, output capacitor, and feedback divider. Therefore, the high efficiency of the LTC3639 is achieved by adding a single inductor, just one more component than an LDO. Here's the LTC3639 in an application with the output voltage set to 5 volts, delivering up to 100 milliamps. On the oscilloscope, the switch node is the top waveform and the inductor current is the bottom waveform. As I increase the input voltage from 12 volts to 150 volts, the time that the switch node is high decreases to keep the output voltage constant. Notice that the peak inductor current remains constant as I increase the input voltage. As I bring the input voltage back down towards 5 volts, the switch node on time increases. When the input drops below 5 volts, the LTC3639 enters dropout, with the top switch on continuously and the output voltage follows the input. The LTC3639's architecture also provides inherent protection against a short-circuited output. When I short the output here with a screwdriver, the switching frequency simply decreases as much as needed to keep the output current under control. When I remove the short circuit, the output voltage returns to the normal regulated 5 volts. Often in the development of a product, features are added and problems are solved that require more current out of the power supply. The LTC3639 contains a simple method for increasing the output current when such needs arise. The LTC3639 provides a feedback comparator output pin, or FBO pin, for combining the output current of multiple LTC3639s, supplying 200 milliamps or more to the output. As shown in this schematic, the 100 milliamp output current of the LTC3639 is doubled simply by adding an additional LTC3639 and an inductor, and by connecting the FBO pin of one LTC3639 to the VFB pin of the other. Any number of LTC3639s can be connected in this manner to provide an additional 100 milliamps of output current per LTC3639. In summary, the LTC3639 offers many great features all combined into one small, easy-to-use IC. These include its wide input voltage range up to 150 volts, high efficiency, a simple application circuit with only 3 external components, and low quiescent current. For more information, visit us at linear.com. Thanks for watching.